Hi everyone, and welcome to the second video of the Peer Club R series. Today I'm going to be talking about data types and structures that you would find in R and work with in R. So there are a few basic types of data in R. So for example, numeric, which are numbers that contain a decimal. And this is almost the same as double, which are double precision floating point numbers, which I had to Google myself, to be honest. So don't get confused by these. If you ever see a double, it's basically still meaning that it's a numeric, I suppose at least, and is, I think, much more used now in the newer packages, such as the dplyr, which comes from the tidyverse packages. So if you see that, it will basically just tell you that it's a numeric variable. Then there are integers, which are numbers without a decimal, something like 1, 5, 17. We have logical data, which is true and false, and also includes the NA. NA stands for not available. And you would use this if you would, for example, have empty cells in your Excel file. And please, if you do use it, then you always spell it with capitals NA. For true and false, which are logical, if you would transfer these into numeric variables, you would have a 1 for true and 0 for false, which sometimes is very useful. But you will see that in the further course of the series. There is another data type, which is character, which usually includes the string values, something like names and labels. And then there is the data type factor, which includes the factors, or in other words, the categories of your data. To check the type of your data, you can either use a logical test, which is something like is numeric or is character, or you can use the function class, which will basically just give you the class. So the output is a little bit different. In the logical test, you would just get either true or false, or if you use class, you would get the actual name of the class, which I will show in a second. And if you're trying to coerce something to a specific data type, then you would use the function as numeric or as factor or as character here. So below are a few examples. So you can check with is numeric if the number 3.45 is indeed a numeric data type, and you would get true as the output. You can check if the string ABC is a character, and again, you would get the output true. And if you're using the function class, as I said before, you would get the actual name of the class here. So I've used the sFactor function here to basically coerce the string hi into a factor and have then wrapped this into the function class, which then tells me that indeed hi is now a factor. It is important to note a difference when you are having numbers which are actually numbers, or if you're having them in the inverted commas. So a number in inverted comma basically automatically becomes a string because this is then dealt with as 3 individual characters, which are 7, the dot, and 8. So if you would run the function as character on this, you would get the output true. If your number, however, is not in the inverted commas, then you would get a false because this number here, so 7.5, now here in green, is indeed a numeric variable. Something that you should remember when you're coercing a factor to a number is that you first have to coerce this factor into a character. So for example, here, the string 25 will then be coerced into 2 individual characters, which are 2 and 5. And then you can use the function as numeric around the sCharacter function, which will then coerce the individual characters into a numeric variable. Okay, so if we do this and basically coerce the string 25 or the factor 25 into a number and save this into an object, which we're here going to call A. And if we then check the class A as an output, you would get numeric. So this indeed worked. And here I'm going to mention again that this arrow that you see here is used to assign something to an object, and we call it the assignment operator. And if you're trying to write this in your code, you can either use Alt +- on Windows or Option +- on Mac computers. When we now go to ecology and the data types we would usually find in our studies, we're talking about something a little bit different. So for example, here the basic types include continuous data, which is something like height, width, length, or temperature or nutrient concentrations. We have discrete data, which includes counts, such as number of species or offspring. We have binary data that only has 2 options, which is something like presence or absence, or yes or no, or it sometimes can just be 1 or 0. Then we have nominal or categorical data, which are species names, sites, and treatments. So this is very similar to something like a factor in R. And we have ordinal data, which are basically ordered categories, something like small, medium, large. So now we're going to switch to data structures in R. So we first talked about types, but now we're going to talk about structures. And here I listed a few of them, which are, I would say, the most common ones. So first is the vector. So this is the most simplest data structure in R and the most basic one. It has only one dimension and can contain only one type of data. So it can either contain numbers or strings or factors or logicals. Then there are lists, which are used to store mixtures of data types. So you can put strings and numbers and factors into a list. I will demonstrate this later as well. So then there are data frames, which you will be probably using the most, and at least I will put most of the focus on using the data frames. Data frames have two dimensions. They have rows, which is the first dimension, and we also call this the observations. And they have columns, which is the second dimension, also called variables. The next data structure is a matrix, which again has two dimensions, and it's slightly different than a data frame, and is mostly used for something like a pairwise comparison. And then there are arrays, which are multi-dimensional matrices and can have an unlimited number of dimensions. So to explain this a little bit more, I'm going to try to graphically represent each of these data structures and just give you some of the code here. But I will repeat most of this code afterwards when we go to RStudio and use the code that I will be providing as well. So if you want to create a vector, you would use the function c. So it's basically just c and then the brackets, and then you would add, for example, numbers inside. So if you are creating a vector, you use this function, you add your numbers, you assign it to an object, which we're going to call a here, and you check the class of a, and it will tell you that this is numeric. If you then try to do something similar, so again, you're generating a vector, but in this case, you're also inserting some strings inside. So for example, we have apples here and we have a puffin here. This then will give you a character class. So as you can see here, we can't combine different classes. And if we do so, there is always going to be one class that is kind of going to dominate. And I will show this later in the script a bit better. One thing that you might have noticed is that I used NAs here. So NAs will not affect the class. So if all other elements of your vector, as in the vector A, are numbers, and you add a few NAs here, the data type of this vector will still be numeric and will not be changed to a character. As said before, data frames, or also Tibble, which is the modern name, kind of have two dimensions. So for example, in this case, we have the different rows and different colors. Each of these rows is one observation. Each of the columns is one variable, and each cell is one value. And below, I have added an example of such a data frame or Tibble. So for example, I use some data that is built in R, which is called msleep. And if you look at msleep, we see here that we have a Tibble with 83 observations and 11 columns. Not all of them are listed here. It's just the first 10 rows that we see. And we see that each of these rows is basically just one observation with a lot of information stored in the different columns, which are the variables here. The next structure is the matrix. Again, two dimensions. Here I have not used any coloring because these work a little bit different than the data frames. And I've just added an example here So what we see in each of these columns are the abundances of different butterflies, and the names of the butterflies are given in the names of the columns. And then on the left, we have this one column that isn't really a column. It's basically just the row names. So it's not really part of the actual data set, which is slightly different to a data frame. But here, each of these row names has basically a name of 1 month. So the data that you see are abundances of different butterflies for the different months within a year. An array is, in my opinion, kind of the craziest data structure. And I'm not really using it a lot because each of these arrays mostly can be transferred into a data frame. And I myself enjoy working with data frames and I'm a little bit even struggling, I would say, with arrays. But this is really just a preference. I know of people who find arrays to be very useful when you're applying multiple functions to the different dimensions. So an array is basically like a matrix with more than 2 dimensions. So each of these bigger squares here is one matrix with 2 dimensions, so dimension 1 and 2. And then all of these differently colored matrices are representing the third dimension. Okay, and as an example, I'm showing here on the right an array, which is the data again built in R called Titanic. And you can see here that it's subdivided into 4 basically main parts, which is the matrix of the first and second dimension. So it has the class and here the sex. And then it has 2 more dimensions. The next one is age. So that's the third dimension, which separates into child and adult. And it has the fourth dimension, which is called survived, which separates into no and yes. And if you want to check on the number of dimensions of this data, you could just type in dim and then the name of the data file or the object that you're working with. And this would give you the number of elements in each dimension. So the first dimension has 4 elements, the second dimension 2, and the third and fourth dimension also have 2 elements. As already mentioned, you can basically coerce an array to a data frame. Sometimes it works easier than other times. In this case, it works really, really easy. So basically, you just use the coercing function as data frame, and then you add the name of the object, which is Titanic. And this then transfers your data into a data frame. And you see the big difference here. So I personally, as I said, am working much easier with a data structure like this rather than an array, but this is again just a personal preference here. So just to explain this, if we now go a slide back, we had here numbers in here, which are basically the frequencies or like the abundance, if you want to call it like that. And we have 2 different sexes. We have 4 different classes here. And then we have child and adult and survived, yes and no. And if we transfer this into a data frame, you have in these first 4 lines, you have the 4 classes, which is the first, second, third, and the crew. And then you have the first level of the sex, which is male. Then you have the first level of the third dimension, which is child, and the first level of the fourth dimension, which is survived. And then you have the frequencies. Okay. And then just below that, the next 4 lines are again the same classes, but now we have here the second level of the second dimension, which is female, and then child, no, and again, the frequencies. So this is another way of showing this graphically, and this is now specific for the dataset Titanic. If you look on the very right side of the slide, we see this one component, which is basically the first matrix in green here. It has 4 observations, which are the different classes. And then it has 2 other columns. One of them has the frequencies for male, and the other one has the frequencies for the female. And then the matrix behind it, if we look now on the left side again, is just the second element of the third dimension. So the first element of the third dimension is child, and the second element of the third dimension is adult. And this third dimension here is called age. So each of these blocks is representing one element of the fourth dimension. On the left, we have yes, and on the right, we have no. And the last data structure for today are the lists. So as I mentioned before, you can here combine different data types and even different data structures within a list. So for example, you can add a numeric vector in the first element of your list. Then you can add a matrix in the second element of the list. And then finally, you can add a character vector in the third element of the list, and so on. So as you can see here, compared to, for example, the vectors themselves, you can here combine different data types and different data structures. So next, I'm going to talk about generating data in R, and I will provide more details in the video later. So for example, if you just want to produce a data frame, you can do the following. You can just add 2 columns, as I'm doing here. So the first column will have the name temp. And if I'm not mistaken, you do not even have to put these names into the inverted commas. I usually do it just to kind of make sure that I'm here really talking about the name of a new column rather than about a variable. So this is the name, which is temp. And then I'm here basically using, again, the function for a vector, which is just C. And within this vector, I'm using the function rep, which stands for replicate. So I'm replicating the string low 5 times and then replicating the string high 5 times and combining these into a vector. And my second column is called growth rate and contains random numbers which are normally distributed. So the first input here is the length of the sample size. The second input is the mean that I chose. And the third input is the standard deviation that I chose. So this is the way how you would generate a data frame. To generate a matrix can be a little bit more tricky. You would use here the function matrix, and then you would first start by adding the data. So I'm here using the function sample, which is basically taking a certain number of elements, which I have specified here to be 72, out of a range of numbers. And what I did here is that I first created a vector that has the number 0 replicated 200 times, and then the numbers 1 to 100. And the reason I did this was just to increase the probability of 0 being sampled here. So I'm sampling 72 times, and each of the values that is sampled from this vector can be replaced. So if the value 100 gets sampled, it can be sampled again. And I'm then subdividing these 72 data points into 12 rows, or in other words, into 6 columns. Okay. So next, I'm adding the dimension names to the butterflies. So dimension names in a matrix have basically 2 parts. So that's why they have to be addressed using the list function. So the first dimension here are just going to be the names of the months. So I'm just using this vector here, which is month abbreviation. And it has 12 elements, obviously. And I'm just going to use all of these elements. So going from 1 to 12. So from January to December. And this is now the first element of my list. And the second element of my list is going to contain the names of the butterflies in my data set. And I will show later how this would look in R. So this is a way how you can generate data in R. But what you can also do is to use built-in data sets in R. And I will again show a few more details in the video later. So usually if you're exercising or trying to get familiar with R, you can use some of the data sets that are already given just to try a few functions before you go to your actual data. And for these exercise purposes, there are data sets that are already implemented in base R or also in some other packages. So the list that you will see always depends on packages loaded. And the easiest way to assess these data sets is basically to just simply type data and then the brackets. And then you're placing your cursor between these brackets or parentheses, and you press tab on your keyboard. And it will then give you this list as you can see below. So if you do not have any other specific packages loaded, you will have probably the air passengers as the first data set to occur. So this comes from the dataset package in R, which is already part of R whenever you install it. And if you have any other packages installed and activated during your R session, then you also might have some other data sets, because there are a few more data sets that are built in, for example, ggplot or into the vegan package. And the last part of the slides for today is how to work with different data structures in R. So we'll cover this part in the video, and I will show you how to access the different elements of each object, so of data frames or matrices or vectors, and how to then subset the objects depending on, for example, a certain condition. So for example, if you want a certain site or a certain treatment, or you just want to extract data that refers to only a few months and so on, all of these things are going to be shown later in this video. I will use different rational, logical, and miscellaneous operators, whatever this word stands for, such as, for example, less than, or equal to, greater than, and so on. You can look at all of these later. One thing that is important here to mention is, for example, if you're trying to compare two things and trying to find out if these are equal to each other, you have to use two equal signs. So we're going to use two equal signs to check if two elements are equal to each other. And if you want to check if these are not equal to each other, you will just use the exclamation mark and one equation mark here to see if the elements you're comparing are not equal to each other. Okay, so exclamation mark usually stands for not. And I will explain all of these later within the video. Okay, so I have now switched to the RStudio and I have already opened the script that I will be using today. I'm also providing this script. You can find it on the Facebook page and you can just download it and then use the script while I'm going through all of these lines today throughout the video and just execute them together with me and maybe add further comments if you want. So there are a few things that I would like to show again, some of which I have addressed in the previous video. So whenever you open your RStudio for the first time, it will probably look something like this. So I personally do not enjoy working with a light background. So what you can do if you want to change the appearance of your RStudio, you can go to Tools and to Global Options, and then you go to Appearance. And here you can choose some of the themes. So I'm going to use the theme Cobalt, as I've showed last time. And also I've noticed that the font size in the last video was slightly small, so I'm really sorry for that. So for today, I'm going to change the font size to 14. And then if you're happy with that, you can apply this to your editor and click on OK to exit the window. If you want to change anything else, for example, the pane layout, you can do this here. So I usually work with these 4 panels being in this order. So source being in the left upper corner, console in the left bottom corner, and then environment and history in the right upper corner, and files, plots, and packages in the right bottom corner. But if you want to work in a different way, you can also arrange this the way you want it. And once you're done with this, you can again press on apply if you have made any changes, or on OK or cancel to close this window. Okay, so now we can start working through the script that I provided. So something that I mentioned last time is that if you're working with a script and you basically want to execute a line, you can put your cursor somewhere in the line and you can either press here on run, or you can just on Windows computers press Control and Enter, and on Mac computers press Command and Enter, which will then send this part of the code to the console and also execute the code. And you will see the output in the console. So what I just did was some kind of a tradition. So every time that I started learning a new programming language, one of the first things that I had to do was basically to just print the words hello world. So that's something that we've done now, so we can check this tradition. And then I'm going to again talk about the arithmetic operators, some of which I have already introduced in the last video. So again, here we have the operator plus, which is for the addition, minus for the subtraction, then the star, that's how I'm going to call it. I think there is another name for this, asterisk or something, that is for multiplication here. And for division, it's basically the slash. Then there are some combinations of operators here. And I'm just going to run this first and let you think first what these might be. So in the first line here, in the line 32, we have the percentage sign and then the slash and then another percentage sign. And it's 15 and then 7 on the either side of this sign. And if we run this, we get a 2. If, however, we only run the 2 percentage signs without the slash, we get the number 1. Any idea? So in the first case, you're just dividing 15 by 7, which gives you 2. So it's only giving you the integer. It's not giving you the actual number that you would get when you would divide 15 by 7. So it's only giving you the integer, which in this case is 2. And this line 33 is basically giving you the remainder of this division. So 15 divided by 7 is 2, and the remainder is 1. So this is why this will give you a 1. I will later in the course introduce you to a function that will use exactly this operator here to do something really, really cool. But that's, again, something for the other videos throughout the series. Okay, so we've been talking today a lot about data types and classes. So again, I'm just going to quickly repeat whatever I've showed you in the slides. So if you want to get a class of the data that we're working with, we can just use the function class. So here, if we type class of 25, it will give me numeric. So it will tell me the actual name of the class. If you do this for the string bird here, it will say that this is a character. So isNumeric is asking if the number 25 is indeed numeric. So we can either get a true or false here. And in this case, obviously, it's true. And if we ask if the string bird is a factor, it will tell me it's false, because we know that bird is only a character here. If, however, you, for example, use something like is logical and then is factor here, you might expect a different output here. I'll just give you a second to maybe think about it. So what we're first doing is that we're first checking if the bird is indeed a factor. And we know from before that this gives us a false, okay? And now we're asking if this output that we're going to get from the inner function here is logical, okay? That might help you. So if we run this, we get a true. And this is the case because obviously the word false indeed is a logical. So don't get confused by it. I just wanted to show it so that you see how these different functions work. Okay. So next we have a in inverted commas. And if we ask for the class here, we get the character, probably the same as you expected. If, however, we first use the coercing function, which here is the s factor, and then we wrap this into the class function, then we get a factor. Okay, so without assigning anything to an object, we're here just basically using two functions combined with each other to then get the actual class of a, which we first coerce to a factor, and then we ask about the class, which as output gives us the factor here. As I've already mentioned before, if you ever encounter a problem where you have numbers that for some reason are treated as a factor, you have to be a little bit careful with the way how you basically coerce them back into a number. So I'm going to try to demonstrate this. So let's just imagine we have a vector here with different numbers. What all of these are now in the inverted commas. So they're basically treated as characters. And then we have the coercing function here as factor. We're saving all of this into an object that we're going to call myFactor1. Okay. So if we execute this, we are not going to get anything in the console except for the actual command line. If you look into the environment here, we see that now we have a new object here, which is factor. And it even tells you here that it's a factor, and it indeed has 6 levels. Okay. And these 6 levels are basically these 6 elements because they're all different from each other. So every time there are different elements, they're all going to be treated as a different individual level. Okay. So something that you would do intuitively probably would be to just use the function as numeric and then insert the name of the object in here. So if you do that, this is the output that you get. So it's the numbers 3, 4, 5, 6, 1, and 2, but they're different compared to the numbers that we actually have in our factor. So why is this happening? Okay, so I already showed you that what you should actually do is to first coerce your factor into a character and then coerce your character into a numeric. Okay, so I'm now going to put this entire part, so assigning all of this into an object, which I'm going to call my numbers, in outer brackets here, which will basically force R to not only assign this into an object and add the object to the environment, but will also give you the output in the console. So it will basically just write out the object my numbers. Okay, so we see the object my numbers here, and these are exactly the numbers that we have inserted before in our factor here in the line 58. Okay, and if we check for the class, it's numeric. So obviously this all worked. So what did happen exactly whenever we were coercing string into a number? So I'm just going to demonstrate this in a different way. So here, I'm going to use words, so just strings within this factor. Okay, and I'm going to save a vector of these strings as a factor into the object myFactor2. And I'm going to check if this is numeric. And obviously, you're going to be like, oh, no, like this does not make any sense. And probably you would expect something like an error or something. However, we get numbers here again. Okay, and this is probably weird. And whenever I was doing this the first time, I was basically having the same reaction as you're probably having now. Okay, but I'm going to try to explain why this happens. Let's try something different and just rearrange the strings that we have in our factor. Okay, so it's again the exactly same strings as before, but just in a different order. Okay. And I'm just going to save them again to a new object, which I'm going to go myFactor3. Okay. And then check if this is numeric. And it will give me, again, some numbers. And it's kind of the same numbers as before, but in a different order, which makes sense because we have just reordered the strings. Or does it? So we can have a last try where we're again going to rearrange them. And in this case, you might even see that the new order is a very specific order. Okay, so it's not entirely random. So I'm going to arrange this and again assign it to an object, which I'm going to call the myFactor4. And again, check and coerce it into a numeric. And I'm going to get the numbers 1, 2, 3, 4, 5. If you haven't figured it out yet, this is the time to reveal everything. So I told you that these factors have levels. Okay, so if we now check the levels of the factor 2, it says it's apple, banana, pineapple, plum, and strawberry. Although this is not the exact order how we had it in the factor, right? If you check the levels of myFactor3, we get the same. And if you check the levels of myFactor4, again, we get the same. Okay. So what R really does is that it orders these levels in an alphabetical order. So obviously apple starts with an A, so it's the first one, then banana with a B, and then we have pineapple and plum, where pineapple comes first, and then last we have strawberry. And if we now look up again, and for example, go to our factor 2, so we have banana here, which is in the first position in the factor, but we know it's on the second position in the levels of this factor. We have apple, which is on the first position of the levels. We have strawberry, which is on the 5th position, plum, which is on the 4th position, and pineapple, which is on the 3rd position. Okay. And now again, if you execute as numeric, we're going to probably get 2, 1, 5, 4, 3. And this is exactly what we get. Okay. So just keep in mind that whenever you have factors, and if you're coercing them into numbers, what R will do is that it will give you the number of the actual level that is in that position. Okay. So if your factor starts with a string that is actually the 5th level of this factor, you will get the number 5 and so on. Okay. I do hope that this is clear. It's sometimes a little bit hard to understand, but I do hope that I was able to show you how to do this. Okay. We're going to go now to logical data, really short. So if we coerce true into numeric, as already mentioned, we're going to get 1. If we coerce false into numeric, we're going to get a 0. Okay. And as I said, this is sometimes useful. You will see it maybe later when we start using these operators to basically subset our data, or if we start using this in some for loops. So just keep that in mind, how this is treated by R. And now we can go to the data structures. So the first structure, again, is going to be the vector here. So I said before, we can assign elements that are all of one data type into a vector. So here I'm using different numbers, and also I have added a few NAs here, and I'm just assigning this into an object that I'm going to call A. And if we check the class of A, it will tell us that this is numeric. If we are now combining numbers with strings, so basically combining numeric variables with character variables, this will give us character as the class. Okay, so we can also check how B looks like here. Okay, so just by executing the name of the object that we just created, just B. And we see here that the numbers that we beforehand didn't have in the inverted commas are now in inverted commas. And this is because R has recognized that you have some of the strings in here in this vector, and has basically just turned all of these elements into strings by just adding the inverted commas. Okay, good. So we're now going to do selecting of elements in a vector. And as I said before, a vector has only one dimension. And the way you can assess the different elements is basically to just type the name of your object. In this case, it's A, for example, and then use the square brackets and just add the number of the position that you're interested in. Okay, so I'm just going to here in the console, again, type A, which will just give me all the elements of this vector. And if we now execute A and then square brackets 5, it will basically just give me the 5th element of this vector, which in this case is NA. Okay. Don't get confused if for example, I think, let me see if this is going to work. Let's hope. If you do a 10, which is more than we have in our vector, it will also give you an NA. Okay, so be careful here that you're aware actually of your length of your vector, so that you're sure that whenever you type in something in here, an index, that is definitely going to be within your actual length of your vector. So if you're interested in the length of your vector, you can basically just type in length and then the name of your vector here, and it will tell you it's 8. Okay, so all numbers above 8 will always give you an A in this case. If you want to access multiple elements at once, you can also do something like this. So it's basically 1 colon 3, which means give me all elements from 1 to 3. So elements 1, 2, and 3. And this is giving you 5, 25.7, 11.2. So these are the 3 first elements of your vector. Then you can also do something like this. So you're basically looking for all elements in A that are larger than 10. Okay. And if you're now looking at vector here, we have the element on the second position, which is 25. Then we have the element on the third position, which is 11. These two are the ones that are larger than 10. And this is exactly what we get, but also we get the 2 NAs here. Okay. And I think that the case is because you can't basically kind of check for the condition when you have NAs. So it will always just give you this NA as well. If you want to kind of ignore the existence of these NAs and remove them from the output, what you can also do is that you first ask for all elements of A larger than 10, and then also all of these elements should not be an NA. Okay, so you use the function isNA to check if A is indeed having elements that are not available, so that are equal to NA. But if you want to exclude these elements, you just use the exclamation mark before that. And you are using this sign here, that's the AND sign, to basically tell R you want these 2 conditions to be true at the same time. Okay, so your element has to be not an NA, and it has to be larger than 10. Okay, and if we execute this, we're going to get exactly those 2 numbers that are larger than 10 and that are not equal to an A. Okay. Then if we go to our vector B, what you can also do is that you, for example, just want to have kind of the tail of the B. So you want to have everything from the 4th element until the very end. So you would just type in the length of B here and then 4 colon length B, and it will give you all the elements from the 4th position until the end. And you can also ask to only give you elements that are not equal to an A, and this will give you all the other strings that are not an A in your vector B. If you're operating on the vectors, you can, for example, calculate the sum of a vector if it's a numeric one, obviously. And if you do sum of A, you will get an NA here. Okay. So this is why you will always have to include this part into functions such as sum or mean or variance. And this will basically tell R to first remove all NAs that are in your vector and then calculate the sum. So be careful when you do that. It depends what data you're using, what functions you're using. Some functions do not have this option of adding the NA remove equals true. So you might have to kind of write your own function to first exclude the NAs and then apply the function of interest. So just be aware of that. And just think if this is something you really want to have or not. In the most cases, you will want to first exclude the NAs and then use a function on a specific data. Okay, so if you do this here, it will calculate the sum, which in this case is 52. What you can also do is that you can multiply your vector with something. And in this case, this worked perfectly. So we just multiplied every element of the vector with a number 5. And obviously, if we have NA elements, we will only get NA as output. And for all other numbers, we're going to get basically the multiplication output from each element being multiplied by 5. So let's now try to do something else, which is basically to calculate the sum of 2 vectors that have the same length. Okay, something pretty easy, I would say. So we're just going to have 2 vectors, 2 new ones, m and n. So we're going to first execute these. And then if we calculate the sum, the way you probably would assume you could do that, it will only give you one single number. Okay. So in this case, sum will just calculate the entire sum of one vector and the entire sum of the other vector and sum these two sums together. Okay, so it's basically just the sum of all elements, and the output is only one single number. If you really want to add the vectors to each other, where you're only summing up each level of your vectors, so you're first summing up the first position from vector m with the first position of vector n, and then in the next step, you're summing up the second position of vector m and the second position of vector n, then you would do it this way. So it's just m plus n. And this will then give you basically another vector that has the exactly same length as the two vectors that you were adding to each other. And now here we have the sum of the different elements, okay? However, if you have vectors that differ in their length, then the elements of the shorter vector will be recycled, okay? So let's just have another vector, which is just having two elements, which are 2 and 4. So it's shorter than m and n. And then we can just try the same as we did before. So we're going to add m plus p. And here it will give us a warning that we have a longer object length, okay, which is not a multiple of the shorter object length, okay, but it will still execute this, okay. And what we see here is that the output is 3, 6, and 5. If you look up to our vector m, we can see that the first sum here, the 3, comes from summing up 1 and 2. So 1 plus 2 is 3. Then we have 2 plus 4, which is 6. And then we have the 3 here. And we are recycling the first element of the vector p. So it's 3 plus 2, which then gives 5. Okay? And we can demonstrate the same if we are summing up n plus p. Again, we get the warning message. And again, the sum does make sense if we remember that the p vector is recycled. Okay, so we have 4 plus 2, which gives us 6. Then we have 5 plus 4, which gives us 9. And then again, we have here 6. And we recycle the first element. So it's 6 plus 2, which gives us 8. Okay, so just keep that in mind. If you're multiplying the vectors, you have to transpose one of the vectors so that it basically looks like a table. Okay, so the first vector here is going to be the I vector. So it's just numbers from 1 to 5. And then we're going to have the J vector, which is going to have numbers 2 and 3. And you see here that it looks like a table. Okay, so it's transposed. And now you can here use the matrix product to multiply these two vectors. Okay, here the first vector is an integer vector. It just has the numbers 1 to 5. And then the second one is a matrix here, okay? And then if you want to multiply these, you would use the percentage sign, the asterisk, and again the percentage sign, and then the two vectors. And then you would get another matrix here, okay, where each of the elements from your vector I, so 1, 2, 3, 4, 5, is multiplied with the first element of your vector j. So that's the first column here. So it's 1 times 2, 2 times 2, and so on. And then the second column here is basically your vector I from 1 to 5 multiplied by 3. And that's why you get 3, 6, 9, 12, and 15. Okay? Good. So we're done with vectors for now. If there are any questions, please just post them as a comment below the video. And I'm going to go to the data frames. So I already showed this in the slides. So we have here the column temp, which has 5 times the string low and then 5 times the string high. And then we have the growth rate, which is basically just random numbers with the mean of 0.5 and the standard deviation of 0.1. Okay, so if we execute this, we're going to assign this to an object, which we're going to call the F for data frame. And then we can look into this by just executing the name of the data frame. And this is how it looks like. Okay, so the numbers here can look different in your case, because obviously each time different numbers are generated. And can also demonstrate this. I'm just going to run this again, and we can already see that the numbers slightly differ for the growth rate. Okay, but they do all still have obviously the mean of 0.5 and a standard deviation of 0.1. And then what you can also do is that you can check only the first few rows of your data set. The default is the first 6 lines, but you can also change this to something else. So we can even, so let's run this first. Okay, so this is just giving the first 6 rows. And if you go to the console again, and just click here, you just press Control and 2, and then use your arrows and just press the up arrow. It will give you the last command that you were just running. Okay, and then you can just place your cursor here and then just type something like 10. Okay, or let's say, let's just do something different. Let's just say 3. And this will then give you just the 3 first lines. Okay, you can also do the same if you want to have the tail of your data set. You would just type the tail, and this would then give you the 3 last rows in your data set. Okay, good. What you can and should also do is always to check the structure of your data frame here. And this will here tell you that the temperature is a factor which has 2 levels, which are high and low. So R is automatically coercing your string vector into a factor here. And you have the second column, which is the growth rate, which is a numeric here. Okay, good. What you can also do is that you just create vectors and then combine them into a data frame later. So we're going to have a vector job, which is just going to have positions such as PhD, postdoc, and so on. Then the vehicle, the salary, and these are basically just arbitrary numbers per month. And then, for example, the age. Okay, and then the only thing you have to consider here is obviously that these vectors should all have the same length. So each of these vectors has only 4 elements. And then you can just combine these into data frames. Just type data frame and then the names of these vectors. And we are going to assign this to another object called dfUni. And if we look at dfUni, it would look like this. So the names of your vectors would then become the names of your columns. And the content of your vectors is then just in each of these columns. Okay. And if we here check the structure, we see that job is a factor and the vehicle is a factor because both of these vectors had strings in them. And then we have the salary, which is numeric, and age, which is again numeric. Okay, and again here the comment, the vectors here have to have the same length. Okay, so selecting elements in a data frame. Different to the vector, data frame has 2 dimensions. Okay, and we can even check how many dimensions exactly you have in your data frame. I already showed this in the slides, so just dim, and then the name of your data frame. You're going to use dfUni. And it will tell you that it has 2 dimensions, basically. The first dimension has 4 elements, and the second dimension also has 4 elements. Okay, and this is important for you just to know what is the range of the elements, basically, that you can kind of subtract or subset and ask for. Next important thing is to know that whenever you use the square brackets here, keep in mind that the first position is always the row. And then the second position in these brackets, so after the comma, is always the column. Okay. If you, for example, want to select a specific row, but you want to select all the columns that you have in your data set, you can just leave this part blank. Okay, so you just do not add a number for the column. And what this will do, it will give you the first row, which is this one here, and it will give you all the 4 columns. Okay. If you just want to subset specific columns and you want to keep all rows, you can just leave this first position, the brackets, empty. Okay, and then just type in the number of columns that you're interested in. For example, I want the columns 2 and 3. You can also put a vector. For example, you could also write C and then 1, 4 if you want the first and the fourth column, and so on. Okay, and this is then the output that you would get. So this is basically getting the data or subsetting your data frame by using the indices within the brackets. What you can also do is that you just use the labels or the names of your columns. Okay, so here we want to have all rows, but we only want to have the column age. Okay, and then if you execute this, you would really get just the vector basically because we only have this one column. Okay. What you can also do is that you add a condition again. So for example, we want to have rows of this data frame where the age is larger or equal to 30. Okay, and we want to have all the columns. And if we execute this, it will only give us the rows for lecturer and professor, because these are the only two rows in our data set where the age is either equal or larger than 30. Okay, and we can do the same, for example, for the salary. So in this case, we want to have the salary equal to 2000. Okay, but also what we want to have is job being equal to PhD. And note that here we're using this sign, for which I don't even really know how it's even called. But just remember that this stands for or. So it's different than the and sign, which is basically looking for two conditions that are true at the same time. In this case, we want everything that is having the salary being equal to 2000. And we also want all the rows that have PhD as the job. So these two conditions do not have to be true at the same time for one row, but they can be true for different rows, okay? But we just want to have either or, and we just want to kind of have the union of these two conditions and not the cross of these two conditions, okay? And this is what we get. So we get the first row here, which is having the job PhD, although the salary is not equal to 2000, but job is equal to PhD. And then in the second row, we have the job not being equal to PhD because it's postdoc, but the salary is equal to 2000. Okay, so this is how you would use the sign for or. You can also use functions to subset your data. So for example, an old school one is the subset, okay, which makes sense. And what you do here is that you first give the name of your object, and then you give a condition. In here, for example, I want the vehicle to equal car. And then finally, already mentioned above, is that you can use the $sign to specify some columns. For example, if you want the entire column job, you can basically just type in df uni and then the $sign job. Or for example, if you want the rows in the column vehicle with the condition of salary being either higher or equal to 2000, you can do it this way. So you first ask for the entire column vehicle, and then in the brackets, you basically just add the condition for each of the rows, okay? And you will see that these brackets have only one dimension, so they have only one position, because you are already selecting a column, okay? So you're kind of removing a dimension already, because you're only looking at this one column, which is in fact a vector, okay? And then the only thing you're asking for really are just the rows. So that's why you need only one single dimension within these brackets here, okay? And this is now giving us the vehicles bike, car, and car, because these are the ones, if you look into our, where is it? In here. So these are the ones where we have the salary either being equal to or larger than 2000. Okay, good. So now we can go to the matrices. As I already showed in the slides, I'm gonna create a matrix here with some randomly sampled numbers. I'm just gonna maybe place this below so that it's nicer. Okay, cool. So you can see everything much better. Okay, so again, we are using this function here, which is taking 72 elements out of this vector here, okay? And each of these elements, once sampled, will be replaced. And we want these data to be subdivided into 12 rows, or in other words, into 6 columns. Okay, so if we execute this now, and then check for butterflies, this is what we get. Again, you might get slightly different data here, because every time you're going to sample, you're going to get different values out of it. Okay, good. And now what we want to have is the dim names of the matrix butterflies. So if we just check for the dim names now, okay, so we can type in dim names and then butterflies in the console, and we're going to get null. Okay, so because there are no dim names, okay, you can see here that all of these columns and rows basically only have the actual index, okay? And this is, by the way, a great example to see, again, how you could access these, because you see here that, for example, the first column has these square brackets where the first position is entirely empty, okay, because it includes all rows, but then the second position has a 1, okay, because it refers to the first column. And the same for the rows. The first row, for example, has an empty second position here, because it should include all columns, but it has a 1 in the first position here because it refers to the first row. Okay, cool. So we're going to add the dimension names to butterflies. We know that the first dimension has 12 elements, and here I'm going to add the names of the months. And if you want to do this, for example, of course, you can either do it manually, but obviously we're going to do it differently. So I'm just going to show how this looks like. So this is not a function. It's kind of a built-in object in R that you can call. If you just execute this, it's just going to give you the abbreviations of all months in a year, obviously ordered how you would usually have them. So if you just want to have the third month of the year, you would basically take the month abbreviation and then put in the number 3 in the square brackets, and you're going to get March. Okay. What we want to have here are all months from 1 to 12. Okay. You can either do it like this, or you can basically just write this without the square brackets. It would work as well. But just for exercise purposes, I thought I'm just going to add this here. And then what I'm going to do is I'm going to add 6 names for the columns. So I have 6 columns here. I'm going to add the Latin names of 6 butterflies here, because obviously we're ecologists, and I'm pretty sure most of you will probably know all of these butterflies here. And then if you do this here and then execute butterflies, then we're going to have this a little bit larger matrix, but you see what happens. So we have the row names here, which are all the months, and then each column has the name of the butterfly. I would definitely recommend not to use names with a space. Okay, so try to avoid using spaces in your column names. You can use spaces in the actual data, and R will transfer this to a dot rather than a space if you should ever use any of your actual basically values in a cell as a name for a column. But if you're generating data, if you're maybe doing it in Excel or anything, just make sure you do not use any spaces and just put a dot or an underscore, or you could even maybe just like combine this to one word, however you want it. The best is, to be honest, to use some kind of a character in between. It would allow you to afterwards separate these words. Okay. So for example, if you need to do any calculations where you just want to kind of separate 2 words from each other, it's always the best if you have some kind of a operator in between, such as a dot or the underscore. Okay. It's getting a little bit dark outside. Good. Now how to select the elements in a matrix, similar to the data frame. Again, we can select the first row by just adding the 1 in the first position in the square brackets and then leaving the second position empty. So this is just the first row here. And then the first column looks like this. So this is the first column, and these are all the months, and then the abundances of the butterflies. Then we want the months January and February here, but all columns. So this would look like this. And then we want to have the months May and July, but only the columns 4 to 6. Okay. And this will then look like this. Good. I hope that is all clear. What you can also do is that you can basically predefine the columns that you are interested in and just put the names in a vector, for example. So you want to have these 2 butterflies. Okay. And then you can assign this as a vector to an object called my columns, for example. And if you're interested only in these columns, then you can include it here in the second position after the comma in your brackets. And then you would get exactly those 2 columns and all rows, obviously. Okay, good. And next are the arrays and tables. So how to generate an array? To be honest, I had to look this up because, as mentioned, I'm basically never working with arrays, but I know of people that use these a lot. And I think they're pretty useful because you can basically assess all these different dimensions within some for loops and something. So if you're doing some multiple manipulation of your data, something like an array might be very useful. Okay, so we're going to generate an array here. So again, I'm going to use the function sample here that will sample 160 elements from this vector here that has 40 zeros and then the numbers 1 to 40. And I will again use replace equals true. So each element that is sampled will be again replaced and can again be sampled. Okay. And then I'm going to just subdivide all of these numbers into, in total, 4 different dimensions with different numbers of elements. And obviously, the dimensions here, if you multiply them, they should basically give a product that is equal to your sample size. Okay, so this is important. So here, the first dimension should have 5 elements, the second 4 elements, 2 elements, and then the last one should have 4 elements again. And if we build a product of this, it's 160. Okay. Make sure that whenever you're generating an array, the product of the elements of your dimensions indeed equals your sample size. If this is not the case, and if your sample size is smaller than the product of the elements of your dimensions, I think that R will just going to put NAs in all basically empty cells. And if your sample size is larger than the product of the elements of the dimensions, then R is just going to discard all the excess elements. So we can execute this here now and then look at our array. And this is how it now looks like. Okay. And again, you see how you would assess the different elements of your array. So again, we have here the square brackets for the rows and the columns. And then if you want any of the other dimensions, you would basically just go to the third and fourth position within your square brackets to assess the elements of the third and the fourth dimension. Okay, good. We're going to now here again add some dimension names. So as we know, the first dimension has 5 elements. So we're going to assign 5 letters into a vector. You could even remove these brackets around it, but I'm just going to do it like this for demonstrative purposes. If you do this, you're not going to see it in the console, but it will appear here in your environment. Then we're going to have 4 different species of Daphnia in this case that we're going to assign to the second dimension. We're going to have good and bad, which we're going to assign to the third dimension that has 2 levels. And then we're going to have numbers 15, 20, 25, and 30, which we're going to assign to the fourth dimension. Okay. So these here are basically the different kind of subnames, I would say, of your dimensions. Okay. So these are the names of each element in your dimensions. And if you want to put these now into the actual dim names of your array, what you can do is that you also give them names. Okay. So the first dimension we will call replicate. Okay. So you're just going to have replicates from A to E. So these are the first 5 letters. Then the second dimension is going to have the name Daphnia, and we're going to have the different Daphnia names inside. The third dimension is going to be called food, and we're going to have the 2 levels, which are good and bad. And the fourth dimension is going to be temperature, which is going to have 4 levels or 4 elements, which are 15, 20, 25, and 30. Okay. And if we then look at our array, this is how it now looks like. Okay. So if we look here, we have this first, I'm going to call it slice, or basically the first matrix, where we have the replicate, which is here in the row names. And then we have the different Daphnia species, which are here in the different columns. So if we look above, we see here that in the third dimension, we are having the level good in this case. And we're looking at the temperature of 15 degrees, which is the part of the fourth dimension. Okay. If you now want to select the elements from an array, we can do this by indexing by position, similar to how I showed it before. So for example, this here are basically double square brackets. Okay. So it's going into the inner part, and it will give you just the 6th element of your array, which is not helping you a lot at all, but just to show you how this would work. If you want to get a specific element, okay, for example, here, all the elements that are associated with the first level of the fourth dimension, okay, then you could write something like this. So we know we have 4 dimensions, so we can put 4 numbers in the square brackets. We want to have all the elements of the first dimension, all the elements of the second one, all the elements of the third one, but we only want to have the first element of the fourth dimension. Okay, if we do that, this is what we get. So it's basically all Daphnia species from all replicates, and it's for the good and the bad food. Okay, but it's only for the first level of the fourth dimension. So it's only in this case for the temperature of 15 degrees. Okay, And then if you, for example, want to get the second, the third, and the fourth row, and then the third column, but you want to have all elements of the third and the fourth dimension, you can do something like this. And this will now give you all the temperatures. So we have temperature 15, 20, 25, and 30. We have good and bad food. Okay, so this looks slightly different than before. And we have only the 3 replicates that are in the second, third, and fourth row. Okay. And we only here have the numbers that are associated to the third column, which in our case was the magna. Okay, so it's only the values that are associated with the species Daphnia magna. Okay, good. If, for example, you forgot the names of your array or something, and you just want to like kind of get the data out of it, but you also want to know which data you're actually looking at, you can just go into the dim names and just extract the names that you need. Okay, so in this case, what we are looking at is the third element of the second dimension, and we know that the second dimension are basically the Daphnia species, and we're looking for the third Daphnia species here, and this will give you the name magna. Okay, as I just showed it above. Good. Then you can also do indexing by name. So for example, again, this would be basically the same as we had it in the line 266, but instead of just giving a number of the column, we're going to give the name of the column here. Okay, so we're only interested in Daphnia magna species. And again, we want to have the rows 2 to 4, but we want to have all elements of dimensions 3 and 4. And then you would execute this, and it will give you exactly the same output as in the line 266. And for example, if you're here interested in, let's say, all of your replicates, but they should only refer to the species Pulix, only come from the treatment with good food, and only come from the treatment with temperature being equal to 30, you could do this like this, and you would just basically get one slice of data, which is this here. Okay, so this is just giving you the number that is associated to the species Daphnia Pulix at good food at 30 degrees for all of your replicates. You can also do the indexing by logical, similar as we did it before. So if we now treat these numbers as the numbers of offspring that each Daphnia produced in each of these treatments, we can, for example, look for all the Daphnia from, let's say, one species, in this case, Galeata, that have produced either 25 or more eggs. Okay, we're going to look at all replicates for which this condition is true. Okay, but we're only going to look it up for the species Daphnia galeata only in the bad food treatment and only at a temperature of 15 degrees. Okay, and if we do this and then look into the my array, we're going to get the number 28. Okay, so this is basically giving us already the actual number of the offspring that we're interested in. Okay, so 28 is the number of offspring from Daphnia that have produced 25 or more eggs, right, at the bad food treatment at 15 degrees. If you just want to see the high offspring vector, okay, it will only give you the logicals here. Okay, it will look into all of your replicates. So it replicates A to E, and it will say, okay, here the condition, if you ask for it, it's false. Okay, and it's again false for B, for C, and for D, but it's only true for E. Okay, I know that this is not giving you much more information than just the number. So whenever you execute 281, but however, this is the way how you would do it. And you just have to be aware what you're really asking for. So you just have to be aware what is the first element in the second dimension, what's the second element in the third dimension, and what's the first element in the fourth dimension. We can check if this output is correct by basically just not providing any row here and just asking for those 3 elements of the 3 dimensions as we had it in the lines above. And then again, we would see here that the first replicate, so the A replicate only had 2 eggs, 15 eggs, and then 0, 0. So the only element that has a number higher or equal to 25 is the last element, which is the replicate E, where the Daphnia has produced 28 eggs. Okay. If you want to operate on an array, you can, for example, use the function apply, which is taking 3 main inputs. which are the object that you're interested in, the margins, and then the function that you want to apply. So in this case, you want to calculate the mean of all replicates for each Daphnia species, for each food treatment, and for each temperature treatment. Okay, and if we do this, this is what we get. Okay, so now basically the replicates are removed, and we have only one single number that we get for each food treatment, each temperature treatment, and for each Daphnia species. Okay, and if, for example, you want to calculate the sum of all eggs for the different temperatures, but you do not care about different Daphnia species or different food treatment, then you only add the number 4 here, which basically specifying that you're only interested in the 4 dimension, but you're not interested in the 3 other dimensions. And then if you run this, you would basically just get the total number of eggs for each of these different temperatures. Okay, good. Then here you should note a difference. If you, for example, use the apply on the array, and here we're gonna basically look at the sum of all eggs for each of the Daphnia species, you're gonna get something like this. If you, however, use the asDataFrame as a wrapper function around this, you're gonna get it in this way. Okay, so this might be also useful for plotting or for saving the data. The only thing you would have to do here would maybe be to just assign this to an object and just change the name of this column to something like sum, and then save it maybe. Okay, this is how you would work with arrays. There are pretty sure other functions that you can also use here, but I just thought that I will introduce apply because there are also other apply functions that can be used on different data structures, and this will be the one that you would use mostly for the arrays. Now we're going to go to the Titanic data set that I already introduced before. So how to call data sets that are implemented in R is really easy. Just type in data and then the brackets, and then you type in the name. Okay, I can also demonstrate something as I did before. I'm just going to cut this out. So if you're here in data, then you have your brackets and you have the cursor in the brackets and press tab, then you would get here, for example, all the elements that we have in the environment. Okay, this is even new for me. But you can also just go here, so you can just scroll down, and then you will see all the built-in elements that are, for example, in the package data sets, which is part of the base R. Put this back. We're going to call this. Okay, so you see here in the environment, it only says Titanic and then promise. Okay, so then if you just run it again, it will then basically execute the whole thing, and it will show you here the actual data set called Titanic, and it will also show you here that indeed it's a table. Okay, I honestly can't really tell what's the actual difference between a table and an array, because for me they look the same and they work the same way. Okay, so just keep that in mind, that apparently in this case at least it's kind of the same thing. Okay, so if we check the class, as I said, it's a table. If we check dimensions, we see it has in total 4 dimensions because we see 4 elements here. Okay, first dimension has 4 elements, then the second one has 2, and also the third and fourth dimension have 2 elements. Okay, and if we check for the dim names, and this is something similar as we had it before with what was it, with our array, we have here the first dimension being called class and having those 4 levels basically. Second dimension being called sex and having the levels male and female. Third dimension be called age and having child and adult. And then the fourth dimension having survived, which is no and yes. Okay. A really easy thing to do here is if you want to transfer this array or table into a data frame, is basically just to use asDataFrame. Okay. And if you do that, we're just going to assign this to a new object that we're going to call df Titanic for data frame Titanic. And if you just run this, as I already showed it in the slides, you would get something like this. Okay. So basically we have all of these 4 dimensions. Okay. And then we have a 5th column, which is having all the frequencies that were inside of those small, basically matrices or the small tables within the array. Good. And the last data structure for today are the lists. We're almost done. To be honest, I also can't really talk anymore. Okay, so as I already said, lists can contain different types or classes of data. And we can just simply put some objects inside that we already have created today. Okay, so we're going to create a list, just call it my list. And we're just going to put the 2 vectors inside, A and B. We're going to put a data frame inside the df uni, the butterflies matrix, and the my array. Okay, all of these just in a function, and that's it. And then if you look at the structure, this is a little bit crazy, but it does make sense. So we see here that we have a list of 5 elements. Okay, the first element being a numeric vector, second element being a character vector, the third element, so each element basically has this dollar sign here, the third element being a data frame with 4 observations and 4 variables. Then the fourth element, again, being a matrix in this case, okay, a numeric matrix because it basically only has numbers inside. And then the fifth element being an array here, which we know because it has here in total 4 dimensions, okay, with different number of elements. And it's numeric because it basically only has numbers inside, okay? Good. And if you want to add a name to each of these elements that are in your list, you can do that as well. So we're just going to, again, basically do the same, but just add the names before each of the elements that we're going to put in. So I'm not going to add the vectors m and I to this list. And again, the df uni and then the butterflies. Okay. And I'm going to all give them names. Okay. So the first vector is just going to be vector 1, then vector 2. And I'm just going to give these two the names as we already used them. So just df uni and just butterflies, and save this as my list 2. And if we check the structure of my list 2, this now looks even a bit better than before. So here we do not only have the dollar sign, but we also have the actual name of the object that we saved in the list. Okay, so the actual name of the element. So we have the element vector 1, vector 2, the data frame df uni, and then the matrix butterflies. And we can check for the names of the list, and these are exactly the names that we have chosen. Okay, good. And how you select elements in a list? So for example, in the first list, as there are no names, you can do indexing by position. Okay, so if you have the square brackets and then you put a 1, it will basically give you the first element in the list. Okay, so it's the entire first element, which is the entire vector. And if you do this, you basically get the same. But what you will see here, and I'm going to demonstrate it, that the class of the output is different. So if you only use single square brackets, then the class is still a list, okay? Because you're taking kind of this whole element out of it, but it also kind of takes part of the list out. And if you, however, go in the list, like really in the list, and just use those double square brackets, then this will be a numeric vector, okay? Good. And if you need more elements, for example, here, oh, it's getting really dark. For example, you want to have the 4th row and all the columns, but you want to have it only from the 3rd element, which we know is the df uni, okay? Then you would get something like this, okay? So we are going to the df uni, and we have here only the 4th row, but all the columns. And if you want to have the 2nd row and the 2nd column of the 4th element, which you know is the matrix, you would do it this way. So in the double square brackets, you would add the number of the element that you're interested in. And then in the single brackets that come afterwards, you would add the dimensions of that element that you're interested in. Okay, good. And yeah, in this case, that's 0. When lists, however, have names, you can also perform indexing with the names. Okay, so here we're interested in the vector 1. So you would just add the vector name or the element name in the square brackets, and this will give you the entire vector. And if you do it in single brackets, it will give you this, okay? And if you now check for the classes, so here using the double brackets, the class will be numeric. Using just the single brackets would again be the list, although we know that df uni is a data frame, and we can just see how this changes if we have the double brackets here. Okay, and here, by the way, if your brackets do not have these beautiful colors, that's probably because you do not have RStudio Preview 1.4. If you do have that, you can, I think in the tools somewhere in the global options, just choose to have rainbow parentheses. Okay, good. So if we execute this now, we're going to have a data frame because compared to what we had before, I'm just going to put it in console. Here, we're just getting the actual data frame rather than similar to here, where we still have this $sign df uni. Okay, so just note the difference here. And I think this is already the last part. You can again here also use the $sign. Okay, so if you just want to assess the metrics here, which are the butterflies, and we have named it in our list, then you can just use my list to $sign butterflies, and it will give you the entire metrics here. If you want to assign parts of your object into another object, okay, you can easily do that. So for example, if you have the df uni, and then you want only the rows where the salary is higher than 2,000, you can do it this way, and this will work, apparently. I would suggest to maybe still include this in here, okay, just to be sure that this is going to work out, and it's going to give you the same, basically. And if you, for example, do that with the matrices, and you just have here, for example, the column for Vanessa Atalanta, which is the red admiral butterfly, you can also just assign this into another object, the red admiral object, and then you would only have the abundances of the red admiral, which is kind of sad that it's all 0 here. But yeah, so that's how you would do it. And that's the end of the script. I hope everyone survived this because I am honestly a little bit exhausted, and it got really, really dark and late. But I hope that was helpful. Let me know if there is anything you didn't understand, or if you have any questions. As I said, just post them in the comments. And I'll see you next time with the third video. Bye-bye.